So I got a question on my last video. In K1, are all product types structural? And I thought it'd be fun to answer it with a little video. So what the question means is, first of all, by product types, it means the types that combine other types together to yield a bigger type in this language. So in our case, they're structs, although the word struct never appears anywhere. It's just the classic object syntax, going all the way back to C and made like super ubiquitous by, I'd say, JavaScript. And then Python also uses the curlies for dictionaries. So the curlies, along with names, colons, pretty ubiquitously meaning an object, right? It might be the best way to think of it, are all object type structural. And by structural, what we mean is defined by their shape alone, or identified by their shape alone, not by also their name or by instead their name. So a great example of a language with only nominal types, might not be only, but for the purposes of the illustration, we could say Java, or let's say Rust. So let's limit it to types that I define. So like in Rust, if I say struct foo, put X and Y in it, and someone else makes a struct with an X and Y of the same types, those types are completely unrelated, right? Even though internally, like they've got the same stuff, no relationship in terms of like a class diagram. One can't be assigned to the other. The compiler just doesn't care that they're the same. And this is rooted in like their name, their identity, the definition. Because they're defined separately, they're different. They're just not, the language isn't interested in the overlap of their shapes. Contrast that with programming in Java, the same. Two classes with the same members, there's just no relationship between them, right? And then contrast that with JavaScript, or let's go with TypeScript, sorry, the actual types, right? Because JavaScript, we just have object. But in TypeScript, I can write an object type, and then I can write one with like one more field, and TypeScript is very aware of the shared substructure, and I can talk about, hey, like this type, but omit this field, or like pick, right? So I'm like, you can think of the types almost like data, where I'm like, ooh, take this one and then add a field name this to it. Take this one and subtract one, or look at the commonalities of these and give me the type that's that, intersect them, right? And you can do that in a language with structural types. Like a way to talk about it is the compiler or the type checker, whatever it is interested in reasoning about like the shape of the types and can like do stuff with it. It might be a decent like layman's way of talking about structural types. And K1 has nominal and structural types. So how are they mixed, and does it work? I think the design is currently not at a great place like syntactically for the difference between them, but I think the story around the difference is like one that I like quite a bit. And after improving the syntax, I think it carries a lot of, I think you can have the benefit of both. So what's really good about nominal types is that they create an abstraction. So that the problem with a structural type is if I want to abstract away the concept of a handle, where I'm going to use the handle to index into this array, but I don't want anyone to access it raw, because like I want to maybe change how it's internally represented. And so I want them to interact with handles exclusively, not indexes. So I wrap it in a struct, right? And right now, K1 makes no attempt to hide the definition of this struct from anyone, but it would be incorrect to take advantage of it, if that makes sense. So, I did have private originally. I don't think that's the answer. I am entertaining a way to make a nominal type, not constructible from outside its module or even its like file, is what I'm thinking of going. But can we set that aside for now and allow that the caller is only going to construct handle like through the means that they're supposed to? Okay, so you're supposed to call make to get a handle, or maybe you call add, right? maybe you call add to put something in the array, and then that gives you a handle. But hopefully we're clear on that. And I might just go ahead and move this up so that it's not distracting, or move it down. So I have 3 ways of defining a type here. So the first I've done with a def type handle and then a struct on the right hand side, this is a nominal type. So it gets its own type ID that is different than the type ID of just writing or spelling that struct literal. Okay, it has an identity, and it's like, it has to do with this definition in this file, and it knows the name. Handle 2, so it's the same thing but with a different name. So these 2 types are different. Okay, and then alias here does not make a type. This purely makes a binding. So after running this line, handle 3 points to this type in this scope. In this scope, there's a named binding. Okay, so no type IDs have been added into the pool of types by this line in the event that this right hand side already existed. If this right hand side didn't exist yet, then we would create this type, but the alias does not create a type. Hopefully that makes sense. So after running this, handle 3 is the exact same type expression as index size. Okay, but handle 2 is not equal to handle, and handle 2 are not equal to handle 3. So what does this mean in practice? So I can create a local h using the structural type, and then I can instantiate the struct. Okay, so this is the structural type of a struct with one field named index whose type is size. Okay, and then h2, these actually are of type handle and handle 2. This syntax is allowed for constructing them, and this gets at, like, do I want this to be allowed? Maybe you want a way to say, hey, no, you can't construct it outside of the companion namespace for encapsulation. But I think it's probably a little bit overrated. Anyway, the reason this works is because the type checker says, I see a struct literal. So in this case, actually, let's not type it. Well, there's 2 cases, okay? I see a struct literal, and I have no type hint, okay? So I'm going to invent a struct, and it's going to be the type of what, like, the values are here. So it makes a type for this, sort of to house it, and then it types h as that type. Does that make sense? But then here, there is a type hint. The type hint is handle. It comes from the variable definition. It could just as well come from here, and it would do the exact same thing. What it means is that when we check this term, we are expecting the type handle. So what we do is we make sure that it conforms. That didn't work. So we may have a bug. Or we just make sure the LSP is running. Highly suspicious. Okay, the problem is we've got errors in this unrelated file. That's fine, maybe I can just fix them, or just call this .k1.whip. Is that fine? Okay. Struct has an unexpected field x. So in here, that's fine, because we're not expecting anything. I'll invent whatever type you want, right? And this term will be typed as that. And this is the type that it invents, by the way. Okay. But here, this is not allowed because I've said, hey, I'm expecting handle. And this is all probably pretty trivial, but the reason I'm trying to build this up carefully is for this next step. There's a difference here internally in the compiler between this type and the other, and that is that at this point now, h1, it's of type handle, and it has what's called a definition info attached to it. So it is a struct. It's not like a wrapper around a struct, like handle is a struct, but it's a struct with a defin info. And like handle 3 is just this struct. Well, handle 3 is a bad example. This is a struct without a defin info. So it's not that handle contains this type. It's that handle is this type with the defin info handle, which is never going to be equal to any other types. Let me show you what I mean in the type checker. So, well, we have a struct type pool. So you can't see it on the type because they're spread out in this array of structs, but every type might have a defin info. And if it does, then it's a nominal type. And a nominal type is never equal to another type that isn't the same nominal type. So if we go to our type eq function, this is the function that says, are these the same type? Now that's different than can one type pass for another? Like if A is expected and B is the actual. So this is, are they equal in terms of like deduplication in the pool, and will we ever have them? And if we look at struct, we can see here that the scalars are like neither nominal nor structural because the structure is fixed. So I call them more something like atomic, right? But then for structs and enums, we look at their defins, right? Their defin infos. And if they're not identical, which means it covers, these are options. So it covers the case if S1 is nominal and S2 is structural, not the same. Also the other way around. If they're both structural, then we'll drop down to here. And if they're both nominal, then they have to have the same name, the same defin info. And then we'll drop down. Actually, if the defin info is identical, there's a chance that we could just say they're equal, but it might, companion namespace. Yeah, for specializations of a generic type, I'm not so sure. So there could be like a missing optimization here. But the point is that if the defin infos vary, then they're never the same type. And what this does mainly is, if we had an ability dereference, right? Then, you know, if I impl dereference for handle, that doesn't mean that it's implemented for the structural type. So doing this does not entail this. And this lets me attach behavior to my abstraction, right? And it doesn't affect the structural type at all. So someone has to use this name and talk about this type with that name in order to access the things I'm defining. Similarly, like if I have a function that takes a handle, they should have to pass a handle. They shouldn't be able to just pass a nominal struct by a different name. Now, can they pass an anonymous struct? You know, this comes down to, I think, whether we consider it privately constructed or not. For now, we're going to allow it, but the main thing that I want to enforce is that they definitely couldn't pass. So get takes a handle, right? So for now, okay, we'll promote the structural type to a nominal, and we could say to do allow private, you know, we'll call it like encapsulated, right? Allow private construction for nominal types. And then this would not be allowed. You would have to make it through something that was defined in here, is I think what I would go with. It's still not going to hide the internals, because I don't believe in that, but it would prevent accidental use of it like that. Okay. This should work because h1 literally is a handle, and then this should fail, but you see right now this is passing. So I thought that we could fix this. because I think I have a special function that's checking the type of structs, and it's not being strict enough with the nominal definition infos. The equality function is, but not check types. So if we go to fun check types, and let's go to struct. We have two structs, and I believe what it might be doing is calling type check struct. Yeah, and this is a really old function. Like this might be a function that I haven't touched in, maybe not haven't touched, but haven't like fully rethought in a long time. And it looks like we're always doing a structural check. So I would like to not do that. Do I have access to the defin infos? For enums, we require that they're the same. So enums are already like good to go. Unfortunately, we don't have type IDs. Like, I'm suspicious that this function even needs to continue to exist. It's only called here. And we may be able to get away with just saying, are they equal? Let me, well, let's do something kind of fun. Let's try that first. So we'll treat them like enums. And we'll say, look, we just got a different one. We got a different struct than the one we expected, and let our structural interning like handle the things we want handled. This can just be like for later once we restore this, but I'm curious what this will do. And they're called R1 and R2 from back when they were called records. So that's how old this is. I bet you things won't pass in the core and standard library, but no, everything passes all the way to here. Expected handle, but got enum. Well, sure, it's not an enum. Let's try that again. Expected struct handle, but got struct, and it's the anonymous one. So this is the one that I kind of wanted to allow promotion, but it's on a check types. So maybe I'm okay with that because, so we're starting to do a little bit of like on the fly design, and it won't necessarily stick, but it's a starting point for thinking about these things. This one works. So we're checking this, and the expected struct is handle, but the thing that we created, yeah, and it's because it's already been created. And if I try and type it as handle here, it's a little bit too late. Question didn't conform to hint, right? So we're failing to type check in the same way. So that's good. I think I might actually be happy with this and require it at construction time. Like when you write the literal, which means that this will actually work for now. Because right now it's a little bit special. When we write the literal, we're looking at, are we expecting a struct? And we'll attach the definition info to it. So we should get to H, right? This one works. It's just this one didn't, because when we constructed it, we weren't talking about handle. But here where we're constructing it, we're passing it to a function that was handle. So it's very reasonable that it should be treated as that type. I think I might just kind of accept this change. It's a little bit scary to try to now run the test suite. I think that we're gonna have a ton of errors. No, I'm not taking advantage of that anywhere. So okay, let's write a function that takes structural, just to close the loop. Okay, it takes that structural type, and it's just going to return empty. And now takes str. Can we do it with h1? We can. Let's make sure, actually. We've changed the compiler since, so maybe we can't now. Yeah, we used to be able to, but now we can't. This one's a structural, but it's been typed as handle. So like some sort of demotion. Well, I'm not even sure. If I wrote a function that just wants this raw shape, yeah, I think there should be something written in the source code here to say, hey, like I want just the structure from h1. I don't want to type it as handle. And this gives us the type separation that is the whole point of having these nominal types, that you have to be explicit and you have to say it's a handle. So yeah, this is kind of my story. You can see it's still evolving around mixing structural and nominal types. The idea is you opt into nominal, currently just by saying def type. And I think, again, I want to make this explicit, even like named type or like unique type. I kind of like, you know, unique is not good because it's like, I can't tell that I'm defining something, but something like this, to opt into nominal types, mainly for like type class implementations, I think it kind of gives you, you know, it tries to give the best of both. So that's what I'm going to pursue. I hope that answers your question, and yes, it'll continue to evolve, but thanks for asking, thanks for watching, and let me know if you what you think of the design. Till next time.